In part 1, you need to evaluate the following expressions. 2x minus 4y when x equals negative 3 and y equals 4. So x equals negative 3, so we're going to substitute that value in for x, negative 3. And y equals 4, so we're going to substitute that value in, y equals 4. Now we simplify this expression and use order of operations, multiplication and division from left to right. 2 multiplied by negative 3 is negative 6. And remember, the sign goes with the term. So this is a negative 4 multiplied by 4, which is negative 16. And then we have negative 6 minus 16. We have more negatives than positives, so we know it's going to be a negative number. And think of a negative and a negative as a dig. You dig down 6 feet, then you dig down 16 more feet, so you're adding the two together. It's going to be negative 22. For question 2, a multiplied by b divided by 2 plus c, when a equals 3, b equals negative 4, and c equals negative 12. So here, a multiplied by b, we have a is 3, b is negative 4, so that's 3 times negative 4. And then we insert the value of c, which is negative 12. I always like to put parentheses around where the variables are, and then that way it helps me organize it, and especially if there's a negative, if this was a minus c, then we would make sure that it's the negative 12 doesn't get confused with this operation sign here. So 3 multiplied by negative 4 is negative 12. And then I bring down the denominator with it. And then I bring negative 12. Negative 12 divided by 2 is negative 6. A negative divided by a positive is a negative. And then we're adding a negative. And again, this is like a dig. We dig down 6 feet, dig down 12 more feet. You've dug down 18 feet. Question 3. In question 3, we need to simplify the following expression. Before I combine like terms, I need to distribute this negative. So the opposite of a positive 4xy is a negative 4xy. The opposite of a positive 3x squared is a negative 3x squared. Now I've colored the like terms to make it easily visible for me to identify each like term. So I have 4x squared minus 3x squared gives me a positive x squared. I don't have any other x terms that are alike, so it's just negative 3x. Then I have negative 4xy plus 3xy gives me a negative 3xy. I have more negatives than positives. So the signs are opposite, so I subtract the 2. And then I have positive 2. Problem 4, we need to simplify the expression. And first I have to distribute this negative. Opposite of 2x squared is a negative 2x squared. Opposite of a negative 3y is a positive 3y. Now I combine like terms. Negative 2x squared plus x squared gives me negative x squared. Then I'm going to combine these three terms. 3y plus 3y is 6y, minus y is positive 5y. And then This has no other like terms, so it's negative 1. In part 2, question 5, I need to find out how many solutions does each equation have. So I'm going to simplify this equation and solve for x. So first I need to combine like terms. 6 minus 3 is 3. Then I need to do inverse property of subtraction, which is addition, because I want to get all of the x's to one side. And I'm trying to get to the side that has a greater value, so that way I end up with a positive variable instead of a negative variable. This created a 0 pair. 4x plus x equals 5x. Still don't have the variable by itself, so I need to move over this negative 12. Inverse property of subtraction is addition. So I add 12 to both sides. Created a 0 pair. 3 plus 12 equals 15. And now I have 5x equals 15. This operation is multiplication. Inverse property of multiplication is division. So I'm going to divide both sides by 5. This gives me the giant 1. 1 multiplied by x will give me x. 15 divided by 5 equals 3. So x equals 3. And even though this is correct, but the proper way to write it is because we were trying to solve for x. So this states 3 equals x. We don't want to know what 3 equals. We want to know what x equals. So this is the preferred way of writing it. X equals 3. And this gave us one solution, because the only value that will make this equation true by plugging it into the x values, into the variables, is 3. And that's also how you can check to make sure your solution is correct. If x is 3, 6 minus 3 is 3. Minus 3 is 0. So this side has a value of 0. 4 multiplied by 3 is 12. 12 minus 12 is 0. So that holds true. 0 does equal 0. So x equals 3. That's the solution. We're still trying to find out how many solutions does it have. But first we need to distribute this term out here. Now, you have to remember the sign goes with the term. So we're not going to distribute a 2, we're distributing a negative 2. So negative 2 multiplied by negative 3x is a positive 6x. Negative 2 multiplied by positive 8 is negative 16. Now I'm going to combine like terms. On the right side, you see there's 2 terms we could combine. On the left side of the equation, there aren't any terms that we can combine. So x plus 6 is 7x. Now, I'm going to do the inverse property of addition and subtract 7x from both sides. 0 pair, and we end up with 2 equals negative 16. And that's not true. So if you get a not true statement, then there's no solution. There's no values that we can put in for x here to make the left side equal the right side. In question 7, we're still trying to determine how many solutions does this equation have. So first I need to combine like terms. On the right side, you see there are no terms we can combine, like terms. On the left side, 3x minus 2x equals x. 9 minus 7 is 2. Well, you can already see that the terms on the left side are the same terms that are on the right side. So by now you should have been able to determine how many solutions this equation has. But if you didn't, we'll just go ahead and keep simplifying this equation. So I'm going to subtract x from both sides, and we get 0 pair, and now we have 2 equals 2. which is true. If you get a true statement where the left side is the same has the same terms on the right side, for example, 2 equals 2, or x equals x, or y equals y, or -4 equals -4, those are all true statements. So a true statement would give you infinite solutions.